So this occurrence of groundwater, it depends upon the porosity of the rocks and permeability of the rocks. What is porosity? So porosity is the percentage of the voids that present in a given volume of aggregate or in a given volume of the soil. So from the total volume of aggregates, the number of voids present in the soil, that is known as porosity. So it is a quantitative measurement of the interstices or voids present in the rock. म्हणजे किती प्रमाणात ते voids present आहेत. Voids or interstices, you can call it as interstices or gap between the particles. That voids present in the rock, that depends upon the formation of the that soil layer, geological formation, the structure of the soil. So that percentage of the voids present in the soil, that is determined. The definition of the porosity is the percentage of the voids present in the given volume of aggregate or soil. Mathematically, you can write this porosity as the porosity is equal to total volume of voids present in the soil, or the volume of water required to saturate the dry sample, that is denoted by VV, volume of voids. VV म्हणजे काय? V suffix V. V म्हणजे काय? Volume. Capital V is the volume. Suffix V is the voids. Volume of voids. Total volume of voids present in the soil sample divided by total volume of the soil sample or aggregate. That is the ratio of VV by V into 100. This is the percentage. The porosity is denoted by letter small n. N is equal to VV by V into 100. That gives the porosity. Volume of voids divided by total volume of aggregates or soil sample. That ratio is known as porosity. So this porosity will depend upon the shape, packing of the soil particles, and degree of sorting of the grains in the soil material. So it depends upon these various factors, porosity. It depends upon the size, shape, the packing or compactness of the soil particles, degree of sorting of this the soil grains. Depending upon this, the porosity will depend. If the soil grains having uniform and well sorted grains, in that case, there will be the higher porosity. Porosity just came aसेल when there is a uniform and well sorted grains are there. Uniform and well sorted grains. There is a uniformity is there in the soil grains, and they are well sorted. They are interconnected with each other. This soil particles, they are interconnected with each other. The soil water will percolate through that voids of the soil. That will be more. The porosity will be more in that case. If the soil is uniform and well sorted grains, and for heterogeneous grains which contains the irregular arrangement, the soil particles that are irregularly that are arranged improperly, or they are arranged in a discontinuous manner, in that case it will obstruct the flow of the water. It will decrease the porosity. Porosity decrease. So it depends upon the arrangement of the particles. How they are arranged. Depending upon that, the porosity will depend. So the porosity of the rocks and unconsolidated materials that may vary. In that cases, it may be less than percentage or more than 50%. In case of rocks or unconsolidated materials, the percentage of this porosity that will be less than or more than the 50%. And in case of poorly compacted materials, it does not exceed 40%. Poorly compacted material असेल त्या केसमध्ये पोरोसिटी जी आहे ते 40% पेक्षा जास्त नसेल. So in general, the porosity is considered as more if it is greater than 20%. In that cases, the porosity will be large. And if it is the porosity is below the 5%, in that case, it is considered as small. The porosity is considered, it is greater than 20%, it is said to be large. And that porosity percentage, if it is less than 5%, then it is considered as small. Percentage of the porosity is less. And in between 5 to 20%, it is considered as medium porosity. So this porosity for different types of rock formation that is given in this table. The diagrammatic representation दाखवले पहा. If that is uniform and well sorted grains are there, in that case the porosity will be higher. The diagrammatic sketch of well sorted grains that is shown in this diagram. The well sorted grains, figure A, that shows the well sorted and uniform grains. These are well sorted. These are the soil particles. Okay, they're all sorted soil particles. The gap this gap it is shown here, whites in this soil grains. These are uniformly and well sorted. Uniformly sorted. Therefore, the porosity will be higher in case of well sorted grains. कुठल्या form मध्ये जास्त असेल that is shown in this figure, well sorted and uniform grains. In that case, the porosity will be more. In case of poorly sorted particles, that is shown in figure B, in that case the porosity will be less. Therefore, porosity in case of A, it is greater than that of B. So in this soil grains that is shown in figure B, the small particles are there, is shown here. Between that large particles, the small particles आहेत. यामध्ये जे गॅप आहे ते गॅप आहे. पाणी इथून फ्लो झाल्यानंतर ते हा जो पार्टिकल आहे तो काय करेल तर त्याला अडवेल. इट विल ऑब्स्ट्रक्ट दॅट फ्लो ऑफ वॉटर. तर तिथे पुढे इथे गॅप आहे. स्मॉल पार्टिकल आहेत. देर आर some large particles are there, some small particles are there. So the flow of the water that is obstructed due to this poorly sorted grains. If it is non-uniform and it is not sorted, in that case the percolation will be less. It will obstruct to the flow of the water, or there may be blockage of water. So it depends upon the that uniformity of the particles. Hmm. Deposition of the soil particle depends upon this deposition of the soil particles. They depend. So this is a figure A. The for porosity for this figure 8 is greater than the figure B. So because in case of figure A, the grains which are having uniform size, equal in size. In figure B, smaller grains that fill the spaces between the larger grains. Therefore, it will reduce the volume of voids, volume of the white space that will get decreased. That will be reduced. So that will decrease the percentage of the porosity. त्या diagram मध्ये दाखवले. समजलं का porosity? Any difficulty in this? Please ask. So this is a table which shows the porosity values for different types of rock formation. The porosity for granite, quartzite rock formation, rock layers. In that case, porosity will be 1.5%. Granite rock असेल किंवा quartzite असेल, the percentage of porosity किती आहे? 1.5%. Then in case of slate or shale, in that case porosity will be 4%. Okay. In case of limestone layer, in that case the porosity will be 5 to 10%. In case of sandstone, the porosity will be 10 to 15%. In case of sand and gravel, the porosity will be 20 to 30%. In case of only gravel, if it is present within the layers of soil, then the porosity will be 25%. In case of only sand, the sand the porosity will be more, 35%. And clay and soil in that case the porosity will be 45%. So it depends upon the rock formation. समझला? So if the soil is having very fine soil is there, the percentage of porosity will be higher. There is the soil having coarse soil is there, coarse aggregates are there. The size increases, this percentage will decrease, porosity will be less. This is the porosity. Porosity of the soil, depending upon that, there is the occurrence of the groundwater. So through that voids of the soil, it will reach up to the groundwater table. This is the first factor, that is porosity. Second one is permeability of the rocks. How much the permeability is there? Permeability of the soil. permeability of the soil. There are different methods are there for finding the permeability. The permeability of the soil. This is one of the important factor. The permeability of the soil means the water that will percolate through the soil particles. The passage of the water through the voids, that is known as permeability. So that permeability of water, permeability of the soil, that is determined uh, by a constant and permeability test or by using variable head permeability test. In the laboratory, there are two practicals are there based on this, finding the permeability of the soil. So this permeability concept that is demonstrated by the researcher Darcy's law has been demonstrated, from which the permeability of the soil that is determined from the Darcy's law. So the zones of underground water, there are different zones of underground water is there. It is shown in this diagram. Zones of underground water. See this. The top layer, that is soil water. Below that, intermediate layer is there. Intermediate water. Capillary fringe water or suspended or gravity water or meadows. Capillary fringe water is there below the intermediate water. Below that, saturated zone is there, saturated zone or groundwater. इथून ते इथपर्यंत काय soil water. Intermediate water is in between that. Above the capillary fringe water. Capillary fringe water or gravity water is above this water table. It is the water table. Okay. This is water table. Below this water table layer, this is saturated zone or groundwater is there. This is saturated zone. That's kind of the zone of saturation. Zone of saturation. त्याच्यावर काय zone of aeration from this. It includes this soil water, intermediate water, and gravity water. Capillary fringe water. Zone of aeration मध्ये. Zone of saturation मध्ये काय येतं? Groundwater or saturated zone. And the addition of this zone of aeration and zone of saturation, त्याला काय म्हणतात? Zone of rock fracture. इथून तिथपर्यंत zone of rock fracture. In between that, it's a zone of from the top surface of the ground up to the this saturation zone below the water table. इथपर्यंत काय zone of rock fracture. Below that, zone of saturation, there is zone of rock flowage. इथून तिथपर्यंत zone of rock flowage आहे. This is a zone of rock flowage. याला काय म्हणायचं? Zone of rock flowage. Internal water. Interstices absent. The internal water. So this groundwater is divided into different zones. हे दाखवले पहा. It is divided into zone of rock fracture and zone of rock flowage. So as we go, as we move down below the ground surface towards the center, this water is available in different forms, in different regions, in different layers. This water that will found in different forms. So this existence of the groundwater, it is divided to various zones. Various zones मध्ये हे त्याचा ऑकरन्स कुठे कुठे आहे, कुठे कुठे आपल्याला हे पाणी आपल्याला कुठल्या लेअर मध्ये अवेलेबल आहे त्या डायग्राम वरून आपल्याला समजेल. So this zones of groundwater, underground water, that is divided into two zones. First one काय, zone of rock fracture and zone of rock flowage. दोन zones मध्ये अंडरग्राउंड वॉटर डिवाइड झाले. त्यामुळे zone of rock flowage, the depth of zone of the rock flowage, it is a zone in which rocks undergo permanent deformation. In this zone, rock flowage, zone of the rock flowage, the rocks will undergo permanent deformation. So this zone, it is not accurately known, but it is estimated as many miles. This zone is, that is the zone of this rock flowage, that is not estimated, but it is having many miles. At a greater depth it is available. So in this zone, that is shown in this diagram, ते दाखवले पहा, हा जो zone आहे, zone of rock flowage, so which contains the internal water. त्यामुळे काय available, internal water. In this, interstices are absent. Interstices or voids are absent in this layer, in this zone. The depth of this zone is not known. It is available at a greater depth, up to many miles. This up to that many miles, this zone is available. It is zone of rock flowage. Above this zone of rock flowage, there is a zone of rock fracture. This is a rock fracture. So in this zone of rock flowage, there is a permanent deformation of rock is there. In this zone of rock flowage, there is a absence of the interstices because the stresses are beyond the elastic limit and rocks remain in state or in the state of or plastic flow. So there, these rocks that undergo permanent deformation. Therefore, there is a interstices that will not present in this zone. The water that is present in this zone, that is known as internal water. The water la काय म्हणतो, internal water. Therefore, hydraulic engineer has nothing to do with this internal water that is available within the zone of rock flowage. Please. Sir, zone of rock fracture that includes soil water, intermediate water, capillary fringe water or gravity water, and saturated zone or groundwater that contains in this झोन ऑफ रॉक फ्रॅक्चर, त्यामध्ये झोन ऑफ एरिएशन आहे आणि झोन ऑफ सॅच्युरेशन आहे, दोन झोन्स आहेत विदिन दॅट झोन ऑफ रॉक फ्रॅक्चर. This is the occurrence. हे काय occurrence of the groundwater, underground water below the ground surface. कुठल्या लेअर मध्ये वॉटर अवेलेबल आहे, विथ zones this water is available. त्या डायग्राम मध्ये दाखवलेले आहे. वेगवेगळे फॉर्म्स आहेत, different forms are there in different layers. This water is available at the top surface. त्या outerला काय म्हणायचं, the water is available at the just below the ground surface, that is soil water. त्याच्या खाली काय intermediate water that is available in the middle of the soil water and gravity water. त्याच्या खाली काय suspended or gravity water. त्याच्या खाली काय groundwater table, below that saturated zone is there. त्या ठिकाणी काय the groundwater which is available below the this water table, and below that internal water is there. It is available within the zone of rock flowage. This is the occurrence of the groundwater. Like I meant the occurrence of the groundwater. त्यानंतर movement of groundwater. Is a movement कसं आहे, how this groundwater move and what is the velocity of this, velocity of flow of the this groundwater. First, this is water table. What is water table? Water table, it is a level of the water. This is static level of water in wells penetrating the zone of saturation. That is called as water table. This is a static level of water in wells penetrating the zone of saturation. त्या झोनला काय म्हणायचं, zone of saturation. Below that zone, within that zone of saturation, there is a water table is available. So it is a static level of water in wells that penetrating the zone of saturation. It is called as water table. It is called water table. The water is available below the zone of aeration. Zone of saturation. The soil is completely saturated. It is groundwater table. Here, dotted line मध्ये दाखवलंय. It's a water table. काय म्हणायचं, water table. So below this water table, the soil is completely saturated. Saturated zone is there. Like I mentioned, saturation zone. This is the definition of water table. It is a static level of water in wells penetrating the zone of saturation. That is called as water table. So this water table is generally higher under the hills and lower under the valleys. Depends upon the replica of the surface topographical area. Depending upon that, this water table it may be higher under the hills and lower under the valleys. And the contour map of the water table in any area may look like the surface topography. So contour map of the water table of any area that may look like a surface topography. So this water table that is constantly adjusting itself towards an equilibrium condition. So that is the water that is moving from the higher points to lower points. So during the flow of the water, that is constantly adjusting its equilibrium condition during the flow of the water as it flows from the higher points to lower points. Then this water table that moves from higher points to lower points. So if there is no recharge or outflow from the groundwater in the basin, in that case, this water table that become horizontal so depend upon the percolation of the percolation through the soil. In some cases, when the percolation is more, the water table rises. So it depends upon the permeability of the soil. This is the water table. So that water table that may near to the just near to the ground surface, or it may be at a greater depth. So it depends upon the uniform recharge conditions and the percolation of water, percolation of to the soil, the permeability of the soil depends upon the, the groundwater recharge conditions. And when there is a intermittent recharge does occur, in that case, the mounds and ridges that will form in the water table under the areas of greatest recharge. So there are different factors are there that may that make the water table less or less horizontal, such as permeability of the aquifers, impermeable strata, influence of the lakes, streams, and whales. In that case, that will make the water table less, depth of water table maybe more, or it may be less. Depends on the several factors. So the movement of groundwater. This the groundwater that moves from the higher points to lower points. As we have seen, the water table is generally not horizontal. It is not horizontal because it moves from higher points to lower points due to gravitational force. That water will move from higher points to lower points. So that the water will flow from higher points to lower points. It reaches at the greater depth below the ground surface. So this is the movement of groundwater that will depend upon the two factors: the rate of the movement of the groundwater. कशावर depend है? That will depend upon the ability of the porous medium to pass water through a porous medium. The ability of the porous medium to pass the water. Permeability वर depend है. The passage of water through the voids. Depending upon that, the movement of groundwater that will depend. The movement of the groundwater that will depend upon the permeability. Permeability कितनी है? The porosity and permeability. त्यावरती depend है. Second one on the drawing force or hydraulic gradient. Hydraulic gradient, depending upon that, that movement occurs. So what is the hydraulic gradient? It is the ratio between difference in elevation of the 2 points on the water table and the distance between them. कशावर depend है? Difference in elevation between 2 points. One point will be at a higher level, and other point will be at a lower level. त्यावरती depend. Hydraulic gradient कशी आहे त्यावरती depend. Whether it's steep or horizontal. Depending upon that, this movement of groundwater that may occur. The hydraulic gradient difference in elevation is denoted by HL. So there is a Darcy's law is there for determining the groundwater velocity. Groundwater velocity किती आहे? Determine करण्यासाठी काय? Darcy's law. Darcy's law that is used for determining the groundwater velocity, groundwater flow. From the experimental evidence which is carried out by Mr. Yash Darcy, who is a French scientist, who have derived this law that is popularly known as Darcy's law. Like I said, Darcy's law. This was invented by Mr. Yash Darcy. कोणी invent केलेले आहे? Yash Darcy, who is a French scientist. He is a French scientist. He was investigated in this Darcy's law in the year 1865. So this is the law related to the rate of flow through the soil. इथे कशावर डिपेंड आहे? The rate of flow of water through the soil or discharge through the soil. Discharge किती आहे? Flow of the water through the soil, through the voids of soil. त्यावरती डिपेंड आहे. So according to this Darcy's law, what it states, the discharge was directly proportional to the head loss. And this discharge is proportional to the length of the soil sample. So that discharge is directly proportional to the head loss. That is divided by HL. So in mathematically, we can write it as Q is proportional to HL by L into A. The equation from the Darcy's law, what it states, discharge is proportional to the head loss. Q is equal to, the equation is Q is equal to HL by L into area. Q म्हणजे काय? Discharge. HL is the head loss. L is the length of the soil sample. A is the area. So from this proportionality, this HL by L that represents the rate of loss of head, त्यालाच काय म्हणायचं? Hydraulic gradient. HL by L म्हणजेच काय? Hydraulic gradient. So this hydraulic gradient is taken as constant, that is I. You can write it as Q is equal to I into A. Again, from this proportionality, you can write it as Q is equal to K into I into A. So this is the equation we get. Q is equal to K into I into A. त्यामुळे K म्हणजे काय? Proportionality constant. So this proportionality constant that will change with the type of soil. Therefore, it is also called as coefficient of permeability. That's command, sir. Coefficient of permeability. Okay. So in that, I is the hydraulic gradient. I म्हणजे काय? Hydraulic gradient. दाखवलं पहा. It is denoted by I, hydraulic gradient. I is the hydraulic gradient. A is the area. Q is the discharge. K is the coefficient of permeability, or it is called as proportionality constant. And this Darcy's law is valid only for laminar flow condition. Ekasadi valid hai for laminar flow condition. The flow of water is, it is laminar. Then in that case, this Darcy's law is valid. For other types of flow, it is not valid. For it is valid only for laminar flow. For from this above equation, dividing this equation by area A, then we get area ni divide केल्यानंतर काय येईल? Q divided by A, KI A होतं. इक्वेशन a by a काय होतं आहे इथे कॅन्सल बोथ इट विल कॅन्सल एनी डिवाइड केले दोन्ही साइडला तर काय राहील q by a की i into a by a कॅन्सल काय राहते only 1 a by a cancels therefore q by a is equal to k into I q by a म्हणजेच काय velocity v तर q आपल्याला माहित आहे q is equal to discharge म्हणजेच काय we know area into velocity okay तर velocity v म्हणजे काय q by a इकडे आलाय q ला डिवाइड झालाय q by a is equal to काय v ओके तर v च्या जागी q by a च्या जागी काय ठेवलंय v आलाय v is equal to k into I is the formula of velocity. In this way, the velocity of flow is determined. समझला v is equal to k into I, where v is the discharge velocity and it is not an actual flow velocity. That it is not an actual flow velocity through the soil medium. So this flow occurs through the voids of cross-sectional area AB. That AB is the area of voids. So when we write this equation as AB into VA and which is equal to A into V. VA is the actual velocity of flow of water through the soil. Actual velocity of flow of water. AV is the the area of the cross section area. Cross section area of that soil layer. Area of cross section. Area of cross section. Area of the voids that is denoted by AV. The actual area is A. Actual velocity is VA. So V काय discharge velocity. Therefore, we can write it as the AV like any divide केले AV into VA divided by capital A. So again, this area is large in comparison. So therefore, we can assume that the ratio of the area of the void A to the total area is the same as ratio of the volume of voids to the volume of total volume. That is equal to N. तर दोन्ही कसं आहे दोन्ही इक्वेट केलेलं आहे volume of voids divided by volume of total volume will be equal to the area of the voids to the total area. AV by A is equal to काय N porosity. तर दोन्ही इक्वेट केलंय. So substituting this value in the equation we get त्या वरच्या इक्वेशन मध्ये ठेवलं तर काय येईल the velocity is equal to AV by A. AV by A च्या जागी काय ठेवलं N म्हणजे काय येईल मग इथे AV by A म्हणजेच काय porosity. Okay, therefore V is equal to VA into काय येईल N. V is equal to N into VA. So from this equation, the value of V, knowing the value of V from this equation and dividing it by porosity N, the actual velocity of flow VA that can be obtained, actual velocity of flow that can be obtained from this equation. V is equal to N into VA. समजलं इथपर्यंत कसं आलंय? Any difficulty? Please ask. In this way, this actual velocity is determined from the Darcy's law. Darcy's law. So Darcy's law for determining the groundwater velocity. In this way, we have derived the equation for determining the actual velocity of groundwater. कशावर पण derive केलेलं आहे? Darcy's law. समजलं इथपर्यंत? Any difficulty? समजलं नसेल तर विचारा. शिंदे, माने, काही डिफिकल्टी आहे का? भागवत, मकानदार, पाटील, हुराडे, गरट, गायकवाड, पवार, सुळे, गोसावी. Anyone having doubt in this?
No doubt, sir.
Okay. In groundwater age, up to we have seen movement of groundwater and its velocity, occurrence of groundwater, movement of groundwater. Then groundwater yield. It is a groundwater yield. So during the flow of the water, the voids present in the soil that gets filled up with water during the flow of water through that interstices or through the voids of the soil. When these voids are completely filled with water, then it is completely saturated. त्यावेळेस ते काय होईल? Completely saturated. म्हणून त्याला काय म्हणतात? Saturated formation. When these voids are completely filled with water, then that layer is called saturated layer, but it's called saturated formation, or it is called saturated zone. So therefore, from this saturated formation where the water is available, the water contained in this saturated formation that is drained out by digging wells under the action of gravity drainage. So this saturated formation, saturated zones that are drained out by the water from the saturated zones that are drained under the action of gravity drainage. So therefore it is found that the volume of water that is drained from this saturated formation is less than the volume of white space in the soil layer. So why it is happens? Volume of water it is less than volume of whites, because entire water contained in the whites of soil that cannot be drained out by the force of gravity, because in that whites that water will be retained, that is stored in that whites due to molecular attraction between the particles. The water is accumulated in that whites of the soil. So that the water that is accumulated in the whites of the soil, so it will not flow. The water that is stored or that is retained in that voids or interstices, this water that is retained in the voids of soil, that water is known as pellicular water. त्या water ला काय म्हणायचं? Pellicular water, the water which is retained in the voids of soil, that water is said to be pellicular water. This is the groundwater yield. त्यानंतर specific yield. Next is specific yield. Yield म्हणजे काय? Yield is the volume of groundwater extracted by gravity drainage from a saturated water, from the saturated formation, that is known as yield. किती प्रमाणात ते पाणी एक्स्ट्रॅक्ट केलेलं आहे from the saturated formation, saturated layer, that volume of water that is extracted, that is known as yield. त्याला काय म्हणायचं? Yield. Yield हे definition आहे. The volume of groundwater that is extracted by gravity drainage, that is called as yield. And this yield, when it is expressed as a ratio of volume of the total material drained or volume of the total material drained or that may be dewatered from the that saturated water zone, saturated water formation. So that is known as specific yield. So like answer specific yield. So it is mathematically, you can write it as it is given in this ratio. Specific yield is equal to volume of water obtained by gravity drainage to the total volume of material drained or dewater into 100. That gives specific yield. The specific yield is the ratio of volume of water obtained by gravity drainage to the total volume of material drained or dewater into 100. That gives the specific yield. So from this, the summation of the specific yield and the specific retention, that is equal to its porosity. दोन्हीचे addition म्हणजे काय? Specific yield and specific retention, that is equal to porosity. त्याला काय म्हणायचं? Porosity. Then specific retention or field capacity. Specific retention म्हणजे काय? It is the quantity of water retained by the material against the pull of gravity. That is known as specific retention or field capacity. So that is given by this ratio, volume of water held against gravity drainage to the total volume of material drained into 100. That gives the specific retention or field capacity. Then I can specific retention or field capacity. So that is expressed in the percentage of total volume of material drained. Percentage मध्ये हे काढलं जातं. Specific retention and specific yield. That is expressed in the percentage. या दोन्हीचे addition म्हणजे काय? Specific retention and specific yield, that is equal to porosity. समजलं इथपर्यंत? Any difficulty? Please ask. समजलं इथपर्यंत specific yield म्हणजे काय? Specific retention or field capacity. After this, there is aquifers and their types. Next is aquifers and their types. What is aquifer? The diagram मध्ये दिले पहा. Diagram of this aquifer and aquiclues. This is aquifer. The non-artesian pervious layer is there. हा जो zone है, it is pervious zone, pervious layer. The water will percolate through this layer. Water table इथे दिले. Groundwater table. Dotted line इथे दाखवले. Okay. The pervious zone त्याला ॲक्विफर म्हणता येते यावरच्या झोनला. झोन इन दिस ॲक्विफर जे खाली विदिन दिस इम्परियस लेअर ॲचड पोर्शन इथे दाखवलेले आहे इथे. इम्परिवियस विच इज इम्परिवियस लेअर, त्याला काय म्हणतात ॲक्विक्लूड. Again below that pervious layer is there. Aquifer having artesian exposed somewhere in the catchment. Aquifer इथे दिले. परत त्याच्या खाली impervious layer आहे aquiclude. So this is the aquifer. So what is definition? Aquifer. This is aquifer. So aquifer is the permeable stratum or geological formation of permeable material which is capable of yielding appreciable quantities of groundwater under gravity. That is known as aquifer. So in a geological formation of permeable material hai, soil layer, within that layer permeable stratum or permeable layer, that layer or that strata which is capable of yielding appreciable quantities of the groundwater under gravity, it is capable of yielding of groundwater. त्याला काय म्हणायचं aquifer. The stratum or geological formation which is capable of yielding the groundwater. ते त्या झोन मध्ये ते काय करतं, त्या झोन मध्ये yielding will be yielding, it is capable of yielding, it will yield, that yielding will occur, that will yield the groundwater in this permeable layers. Aquifer. This is the aquifer. Non-artesian इथे दाखवलं पहा आणि इथे artesian aquifer. Aquiclude. This is the aquiclude. So the term appreciable quantity is related depending upon the availability of the groundwater. Then next is aquiclude. This is the aquiclude. So when an aquifer which is overlain by a confined bed of impervious material, then this confined bed of overburden is called as aquiclude. Like aquiclude. So which is laid, the aquifer is laid above this impervious layer. हा impervious layer आहे. या impervious layer च्या वर काय आहे? Pervious layer. In that aquifer is there. Aquifer aquiclude च्या वर आहे. Which is overlain over this aquiclude impervious layer. So this zone is known as aquiclude. Like काय म्हणायचं aquiclude. So this aquiclude that is laid. It is confined bed of overburden, confined bed of impervious material. So yielding from this aquifer, that depends upon the several factors. Depends upon the diameter, well diameter, and depends upon the permeability, thickness, permeability of the water through that layer, and thickness of the layers. This is the aquifer. समजलं aquifer म्हणजे काय? Aquifer आणि aquiclude दोन different आहेत. So these aquifers that may vary in depth, lateral extent, and thickness. So these aquifers, all these aquifers having different depth and different thickness. So that all these aquifers that will fall into two categories. त्यामध्ये दोन types आहेत aquiferचे. One is unconfined or non-artesian aquifer, and second one is confined or artesian aquifer. Unconfined असेल तर त्याला काय म्हणायचं? Unconfined aquifer म्हणजेच काय? नॉन आर्टेशियन aquifer. Confined aquifer म्हणजेच काय? आर्टेशियन aquifer. दोन टाइप्स आहेत. इथे दाखवायला पहा डायग्राम मध्ये. Unconfined, that is non-artesian. Unconfined means non-artesian. Unconfined. Confined, it is called artesian. This is confined. This is confined. This is unconfined, non-artesian, and this is artesian. त्यामध्ये फर्स्ट आहे unconfined aquifer, second one is confined aquifer. The unconfined aquifer, it is also called as non-artesian aquifer. It is unconfined. The unconfined aquifer म्हणजे काय? The topmost layer, topmost water bearing stratum having no confined impermeable overburden lying over it, that is known as unconfined aquifer or non-artesian aquifer. हे diagram मध्ये दाखवले पहा. The topmost layer, this layer. So it is unconfined. हे कसं आहे? Unconfined. It is non-artesian aquifer. हे कसं आहे? Confined आहे. म्हणजे वरच्या लेयरला ते ओपन आहे, एकीकडून ते कन्फाईन आहे. इथून below this layer, pervious layer, it is confined. Above this वरच्या लेयर ग्राउंड सरफेस आहे, ते ओपन आहे, म्हणजे ते that is unconfined. याच्या खाली आर्टेशियन आहे, आर्टेशियन इथे आहे विदिन दिस. तर दोन्हीकडून एक कन्फाईन, दोन्हीकडून ते काय केलेलं आहे, क्लोज केलेलं आहे. वर काय ॲक्लिक्लूड आहे, इम्परवियस लेअर, खाली सुद्धा ॲक्लिक्लूड आहे, दोन्हीच्या मध्ये आणि ते कन्फाईन केलेलं आहे. इट इज in between that aquiclude. Therefore, it is called confined aquifer. Like confined. So the ordinary gravity wells of 2 to 5 meter diameter, which are constructed to tap water from the topmost water bearing strata. So in these cases, in the unconfined aquifers, the ordinary gravity wells that are constructed of diameter 2 to 5 meter diameter to tap the water from the topmost layer. या अनकन्फाइंड ॲक्विफर मधनं हे पाणी काढलं जातं. ते कशामधनं काढलं जातं? फ्रॉम दिस टॉपमोस्ट लेअर, फ्रॉम दिस अनकन्फाइंड ॲक्विफर्स. त्याचं डायमीटर किती असते? त्या वेलची डायमीटर किती असते? 2 to 5 मीटर डायमीटर. म्हणून त्याला काय म्हटलेलं आहे या वेल्सला? अनकन्फाइंड वेल्स और नॉन आर्टेशियन वेल्स. म्हणजे इथे जे वेल्स घेतले जातात इथे ॲक्विफर नॉन आर्टेशियन, सपोज इथे आपण वेल एक्सक्युएट केलंय, दिस इज अ वेल. याचं ते डायमीटर किती असते? डायमीटर ऑफ दिस वेल इज 2 to 5 meter. That is taken, that is excavated in this aquifer, in the top portion, top layer. म्हणून त्याला काय म्हटलेलं आहे? अनकन्फाइंड वेल और नॉन आर्टेशियन वेल. या वेलला काय म्हणतात? आर्टेशियन, नॉन आर्टेशियन वेल और अनकन्फाइंड वेल. नंबर ऑफ इन दिस लेयर, नंबर ऑफ वेल्स that means इथे एक असेल, इथे एक असेल. The wells having 2 to 5 meter diameter. या डायग्राम में दाखवले पहा. अनकन्फाइंड हे वरचं लेअर, टॉप लेअर आहे, टॉप सरफेस. The water level in well is equal to the level of the water table. The water table इथे दाखवले. वॉटर टेबल इन द वेल इथे दाखवलं पाहिजे. वेल म्हणजे पाणी कुठपर्यंत आहे? या वॉटर टेबल पर्यंत. The first well it is shown here, second well, ground level. Water level in the well it is shown to this groundwater table. Aquifers is sand and gravel. Sand and gravel layer is there. The wells है, the first well is second well, unconfined well or non-artesian well. पाण्याची लेवल या वेल्स मध्ये दाखवले पहा. Is a non-artesian or unconfined aquifers and wells. Okay. समजलं का? अनकन्फाइंड ॲक्विफर म्हणजे काय? So the water level in this well will be equal to the level of water table. जे वॉटर टेबल जिथपर्यंत त्यामध्ये पाणी असतं वेल्स मध्ये. The water level in this well will be equal to the level of the water table. Both are equal. So therefore these wells are also known as, these are said to be gravity wells. याला काय म्हणायचं? Is simply called as wells or it may be called as unconfined wells or non-artesian wells, or it is also called as gravity wells. यालाच काय म्हणायचं? Gravity wells. त्याचं दुसरं नाव आहे gravity wells. The second one is confined aquifers or artesian aquifers. Confined म्हणजे काय? When an aquifer is confined on its upper end under the surface by impervious rock formation, that is confined between the two rock formations, is confined between two aquicludes, impervious rock formation, that is called as aquicludes. It is also broadly inclined so as to expose the aquifer somewhere to catchment area at higher level for the creation of the sufficient hydraulic head. In that case, this aquifer is confined between the two impervious rock formation. म्हणून त्याला काय म्हणलेलं आहे? Confined aquifer. ते दाखवलं पाहिजे डायग्राम मध्ये. It's a confined or artesian aquifer. This is enclosed, which is closed by this aquicludes on both sides. हा झोन काय आहे? या लेला काय म्हणायचं? Aquifer ला confined aquifer or artesian aquifer. समजलं दोन्ही मध्ये डिफरन्स काय आहे? Unconfined aquifer and confined aquifer. मध्ये डिफरन्स काय आला? So the wells which are taken to this aquifer that will yield water that often flows automatically under the hydrostatic pressure. Under the hydrostatic pressure, the water will flow out to this wells. Any difficulty? Any problem? So through this well, the water will rise out of the surface at a suitable height through this well. And when the ground profile is high, the water will remain below the ground level. If the groundwater ground profile is high, in that case water table that will remain below the ground level, ground surface. As in case of artesian well, non-artesian well, the water will remain below the ground surface. In case of artesian well, the water will flow out automatically. Therefore, this type of well is also known as flowing well. त्यालाच काय म्हणायचं? Flowing well. The confined and or artesian aquifers and wells that is shown in this diagram. The impervious aquiclude आहे जे वर दोन्हीच्या मध्ये काय परवियस आर्टिशियन ॲक्युफर इथे दिले पण pervious artesian aquifer that is of sandstone. Okay, the impervious aquiclude आहे ते shell having metal shell is impervious. दोन्हीच्या मध्ये काय artesian aquifer which is of sandstone pervious आहे. इथे वेल्स दाखवले पहा. फर्स्ट वेल वॉटर टेबल इथे दाखवलंय. ओके, इथे वॉटर टेबल is below the ground surface या दोन्हीच्या first and second recharge area in the catchment ते दाखवलंय. Well number 1 and 2 are non-flowing artesian wells. These are non-flowing artesian wells. कारण इथे वॉटर टेबल जी आहे त्या ग्राउंड सरफेसच्या खाली आहे. इट इज नॉन फ्लोइंग. And well number 3 is flowing artesian well. It flow होता continuously. That through that well the water will flow out. Water flowing out under the hydrostatic pressure. पाणी हे पूर्णपणे हे भरून गेलेलं आहे. The well is flow over this flow. It is completely filled with water. नाही तर पाण्याची लेवल इथपर्यंत दाखवले पाहिजे म्हणजे ते पाणी बाहेर आलेले आहे. It will flow out under pressure. This well, third number well. This is the imaginary pressure surface or piezometric surface. इथे दाखवलंय dotted line इथे दाखवलंय. This is the confined or artesian aquifers. And if the pressure surface, if the groundwater, the water table that lies above the ground surface, in that case, the well is said to be flowing artesian well. त्याला काय म्हणायचं flowing artesian well. And when the pressure surface, that piezometric surface that lies below the ground surface, then in that case, that well is said to be artesian well or non-flowing artesian well. तर त्यासाठी काय लागेल? To lift that water, pumps are required to bring the water to the surface. Therefore, this non-flowing artesian are also called as sub-artesian wells. त्याला काय म्हणायचं? Non-flowing artesian wells ला sub-artesian wells. Okay, so these are the types of aquifers: confined aquifers and unconfined aquifers. The remaining part we'll see in next lecture. इथपर्यंत काय डिफिकल्टी आहे का? समजलं नसेल तर विचारा. Can unmute yourself or can ask in chat box. Okay, we'll stop here. Everyone give attendance in chat box.